Okay, we're going to talk about compound inequalities today. This is a little more involved, so we're going to go ahead and get started. This video may take a little while because I want to do a lot of examples in order to make sure that we fully understand this concept. We're talking about compound inequalities. We're going to be looking at two significant key words. One of those is and the other one is or. Just like in English, your compound sentences are like when you have two sentences combined by the word and, or two sentences combined by the word or. Okay, so it's the same idea. When you have and, you have an intersection. That means that there's going to be things that you have in common for both answers, both solutions. Because what we're going to do, when we're talking about compounding inequalities, you're going to have two inequalities, almost like a system, but it's not a system, so don't get that confused. But you're going to have two inequalities, and essentially you're looking for what they have in common. When you graph these compound inequalities, there's not going to be a gap in between your graphs. Okay? The circles on your graphs, because like I said, there's going to be two of them in most cases, the circles in your graph are going to connect. And essentially, in order for you to have a solution to this inequality, you must meet two conditions. Okay? So those are the things that we're going to talk about when we talk about a compound inequalities dealing with and. The cool thing about and too is you can also write those in a shortcut form. And we'll talk about that a little later on. We're also going to do a compound inequality dealing with the word or. The or is called a union. Okay, all you have to do is meet one of the conditions. So if you want to get hired for a job, you have to be 21 or have a high school diploma. So if you're 21, you can apply for the job, or if you have a high school diploma, you can apply for the job. You don't have to be both. But if the job said, hey, if you want to apply for the job, you have to be 21 and have a high school diploma, then you'd have to meet both those conditions. That's the difference between and or. Also, when we graph the or inequalities, we're going to have we're going to have gaps. That means the circles are not going to connect. Okay? And there's no simple way to write the or. You're going to have to write the word or most of the time. There is a union symbol we're not going to talk too much about right now. All right, so let's get started. In our first example, what we want to do is we want to graph x is less than or equal to 14 and x is greater than or equal to negative 2. Again, here's what we want to do. We want to first start off by drawing our number line. And this time you're going to need more than just one dash. So now I have 14, and make sure you put it in the right spot. And 14 is a positive number. And then I have negative 2. I'm going to put it right here. Okay? Again, I know that 14 came first, but look at how the order of the number line goes. Positives on the right, negative on the left. Okay? Now, let's just start with graphing one at a time. So let's start with graphing the x is greater than or equal to 14. So let's go to 14. How do you graph that? Is it open or closed circle? Yeah, you're going to have a closed circle. Great job, Kirsten. Okay. And then is the x on the left side? It sure is. So that means that we're going to draw our arrow in the direction of whatever the inequality sign is pointing. In this case, it's pointing to the less than. It's pointing to the left. So we're going to draw our our graph to the left. Like this. Okay? Now let's go ahead and graph the other one. So if we graph this one here, what kind of circle are we going to have on this one? Yeah, because it's equal to, we're going to have a closed circle, a negative 2. Great job, Jefferson. Okay, now, is the x on the left-hand side? Yeah, it sure is. Okay, so which way are we going to draw our arrow? Well, the inequality sign is pointing us to the right, so we're going to draw our arrow to the right. Now, I could draw my arrow and keep it going out here and go on forever. But what you're going to notice, and I can do it with the other one too, it could go on forever. But what we're looking for is we're looking for the spot where they connect. Okay? So here's our closed circle. Here's our closed circle. And my solution is going to be that big dark line where they overlap. That's all I need to graph when I graph. I don't want to graph all this stuff right here or this stuff, because that's not relevant. The only part that's relevant is that dark, thick yellow line, okay? So that is, we're dealing with and, we have to meet both conditions. So all these numbers on that dark yellow line, are including 14, are less than 14 or equal to 14, and they are greater than -2 or equal to -2. So every number, so pick a number in between -2 and 14. Okay, let's just say we pick 6. Good choice, Nathan, okay? So if we pick 6 there, is 6 less than 14 or equal to 14? Yes, it is, so it meets that condition. Is 6 greater than -2 or equal to -2? Yes, it is. So all those numbers on that spot are going to be your answer. Okay, if you have any questions, as always, write them down and ask me in tutoring or during class. Okay, so let's move on to example 2. That was an and statement. Okay, that was a key word, and. Okay, now we're focusing on an or statement. Okay, again, draw your number line. You're going to need 2 spots because we have 2 numbers that we're dealing with. Again, make sure the spots are in the right spot, the numbers in the right spot. So we're dealing with 0 and -4. -4 is less than 0, so it's going to be on the far left. And again, just like we did before, let's just start with one or the other. Okay, so we're going to start with x is less than -4. Okay, so I'm going to graph. What kind of circle am I going to have? That's right, Zach. I'm going to have an open circle. Is my x on the left side? It sure is. Okay, so now, which way is my inequality sign pointing? It's also pointing to the left, so I'm going to draw my graph this way. Okay, let's go ahead and go over here to x is greater than 0. Okay, what kind of circle am I going to have? Hey, very good, Kaylee. I'm going to have an open circle. Okay, which way is my my inequality pointing to? Because I'm on the left side, so I can use that. Inequality is pointing to the right, so I'm going to draw my arrow to the right. Now notice, I don't have any overlapping here. I have one going this way and one going this way, and all this is an empty gap. When I was talking about gaps earlier, that's exactly what I was talking about. So in order for this to be true, any number less than -4 is going to work, and any number greater than 0 is going to work. It doesn't have to be both in this case. It's one or the other. And I have a gap in my drawing, and it's going to be okay. All right? Any questions on that? So essentially all I'm doing is graphing 2 inequalities on the same number line. And they should be going in the opposite direction. Okay? Let's look at example number 3. Now here's a unique way to write a particular compound inequality. What this says, if I break this up, I can break this into 2, and I can say that x is greater than or equal to -10, and I can also say that x is less than -3. And so now I have 2 different inequalities that I'm going to graph here in a second. This special writing, the way this is written, okay, indicates to you that you have an and compound inequality. So this says that x is greater than or equal to -10 and less than or equal to -3. So this is an and inequality. Now watch how you can graph this one. Generally speaking, this should work out if it was written right. What you can do is drop down the -10 and drop down the -3. Just go ahead and drop those on there. And drop the -3. Go ahead and put your circles on there. What kind of circle am I going to have for the -10 one? Yeah, I can either look here or I can look over here in the original equation. And that's right. I'm going to have, good job Brayley, a closed circle. Okay? And then over here, the x is less than 3, or less than -3. What kind of circle am I going to have? Very good, Kira. An open circle. Okay, and basically what an and statement says, the reason I like this particular way to write this is because what this is telling me is that x is in between -3 and -10. So what I'm going to do is I'm going to connect right here. So x is greater than negative 10. It's all these numbers right here, but less than negative 3. So all I'm going to do is shade in between. Because when you have an and, x is in between negative 10 and 3. Or it could also equal negative 10. And that's it. That's a compound inequality using and we just graphed it. Okay? All right, let's move on to example 4. On example 4, we're getting a little more challenging because now we're going to have to solve the inequality. You still have to have the variable by itself in order for you to do this fully. Okay, so the first thing we want to do is solve the inequality. Now, you might be asking yourself, how do you solve the inequality when it's in the middle? Well, that's a great question. What you're going to do is, if you use the river method, like I taught you at the beginning of the year, you can draw a river here and draw a river here. So a river there and a river there. And what you're going to do is whatever you do to one side, you're going to do it to every side. So like to get m by itself, I've got to add 1 to both sides, right? So I'm going to add 1 to both sides. But I'm going to add 1 here and I'm going to add 1 here. So that's going to give me 4 is less than 2m, which is less than or equal to 10. Okay? Now I got to get rid of the 2, so I'm going to divide both sides by 2. And again, in this case, I'm going to divide all sides by 2. You got to do it to both of the sides of there. So 4 divided by 2 now leaves me with 2 is less than m, which is less than or equal to 5. So now we've isolated our variable. We are ready to go ahead and graph now. So again, I have a compound inequality, so that should indicate to you that we have a and compound inequality, so that's good. So you can draw your number line. Drop down the 2, drop down the 5. Put your circles on there. What kind of circle am I going to have on the 2? Very good, Haley, an open circle. What kind of circle on the 5? Very good, Brunick, a closed circle. Okay, and then of course my answer is in between those numbers, so I'm just going to shade everything in between. And voila, we are done. Great job to everybody. All right? And again, if this is going too fast for you, if you don't catch it the first time, I encourage you to re-watch these videos and check it out again, okay? Let's look at an example number 5. Now we're dealing with another one that we have to solve, but in this case it's or, so it's clearly set up. You have two equations all by themselves, so we can just go ahead and draw a river for this one and draw a river for this one and just solve both of those. So to get x by itself over here, I've got to subtract 5 from both sides, and I get x is less than or equal to negative 16. Over here, I've got to add 5 to both sides, and I'm going to end up with 2x is greater than or equal to 16. Divide both sides by 2. And x is greater than or equal to 8. Okay, so now I've solved both my inequalities. So now I need to go ahead and graph them. And now we're dealing with an or. So what should we be looking for when we deal with an or? Yeah, that's right. You're exactly right there, Candace. We're looking for a gap in between. Okay, so let's go ahead and drop down our numbers. We have negative 16 and 8. What kind of circle am I going to have on negative 16? Well, it's less than or equal to, so I'm going to have a closed circle. Okay, which direction is my inequality pointing? I can use that because the x is on the left-hand side. It's pointing to the left. So here's one way. What kind of circle am I going to have on the greater than side? I'm sorry, on the 8 side. Very good, Caitlin. I'm going to have a closed circle because it's greater than or equal to. And which way is the arrow pointing? Since it's on the left, it's pointing to the right. So I can go ahead and draw my arrow to the right. Great job. All right, let's keep moving forward. Okay, example number 6. And again, a lot of examples, so to make sure you fully understand this. Here again, we have a compound and inequality because it's in between. Let's go ahead and draw your rivers. And let's solve this. Okay, you got to get x by itself, so I'm going to subtract 5 from all sides. It's going to leave me with negative 20 is less than or equal to x, which is less than or equal to 6. Went ahead and solved that, so we're good. So now all we got to do is draw our number line to graph it. Okay, so I'm going to drop down my negative 20 here, drop down my 6. Those are in the right order. That's good. What kind of circle am I going to have on the negative 20? Yeah, that's right, Luke. A closed circle. Good job. Okay, which kind of circle am I going to have on the 6? That's right, a closed circle. Great job, Ruby. Now, all my answers are going to be in between negative 20 and 6, so I'm just going to graph and highlight right there. And that does it for example number 6. Okay, example number 7, we're going to have to translate in order to solve. So let's go ahead and start translating. It says on an interstate highway, the maximum speed is 70 miles per hour, and the minimum speed is 45 miles per hour. Okay, if x represents the speed, then write an inequality express this condition. Okay, so I can have a maximum speed. So that means x has to be what? Greater than or less than 70? Yeah, if it's a maximum, that means 70 is the highest. Everything else has to be less than 70. So x is less than 70. If I have a minimum speed of 45 miles per hour, that means x has to be what? 45. Yeah, greater, because 45 is the lowest you can go. Now look, this is an and situation, okay? You have to, the way you can look at this is you have to go, when you're driving on the highway, you have to go 45 miles per hour or faster. With that being said, I need to make this equal to, but I can only go up to 70 miles per hour. So I got to make that equal to 70 miles per hour. So I can go 70 miles per hour, but no slower than 45. So is that an and or statement? I have to go 70 miles per hour. I have to go slower than 70 miles per hour or 70 miles per hour, and I have to go faster than 45 miles per hour or equal to 45 miles per hour. So that's an and statement, right? So I'm going to rewrite this. Let's rewrite this to make it easier. Let's stick x in the middle. And then what you do is you put your minimum number, your smaller number, on the left side, and your bigger number on the right side. And then you put in the inequality. X is what to 45? Look here. What is this sign? X is greater than or equal to 45. What about x compared to 70? Yeah, it's less than or equal to 70. So here, we just wrote an inequality to represent all the speeds in between 45 miles per hour and 70 miles per hour. Okay, and we're not going to graph this one because we've done a lot of graphing on that, but you would graph this. Would it have a gap or no? Yeah, very good, Gracia. It does not have a gap because this is an and statement. Okay, let's look at number 8. On 8 and 9, we're going to write the inequalities for ourselves. Okay, does this graph have an inequality? Does this graph have a gap? Yeah, this right here is a gap, right? Okay, since it has a gap, we are going to go ahead and make this an or statement, right? And so all we got to do is make two inequalities. So what is this inequality here dealing with the negative 3? What do you know about all the numbers with negative 3? Well, all these numbers are negative 4. That's all going to the left, which is negative 4, negative 5, negative 6. What can you say about those numbers? Yeah, that's right. X is less than negative 3. Is it equal to? No, it's not. Very good, Haley, because it is not equal to because it's got an open circle. All right. What about the other side? What do you know about 5 and all the numbers with 5? It's going to the right, meaning it's going to be 6, 7, 8. So x is going to be greater than 5. Is it going to be equal to? Very good, Lila. It is going to be equal to because it's got the closed circle. So then what you would have is x is less than 3, negative 3, or x is greater than or equal to 5. And there's your solution. Okay, that's a little more difficult, challenging to do, but once you get a full understanding of it, it's really not that hard at all. All right, let's look at our next example, number 9. On number 9, notice, do we have a gap? Yeah, there's no gap here. And since there's no gap, that means we're going to be dealing with an and. Okay, so let's just stick x in the middle. What do we know about x? Actually, we won't stick x in the middle. Let's just say, just tell me, what do we know about x? All right, good. Luke, we know that x is greater than 8. Why is it not equal to 8? That's right, because it's got an open circle. What else do we know? Yeah, because all these numbers are greater than 8. You see that? 9, 10, 11. Good question, Mariah. Good question. All these numbers are greater than 8. 9, 10, and up to 11, right? What else do we know about x? Good, JD. X is less than or equal to 11. Why did JD say it was equal to? He said it was equal to because you have a closed circle. And all these numbers are less than 11. 9 and 10 and so on and so forth. But remember, we're dealing with an and statement. So let's stick x in the middle. Let's stick our big number out here and our small number over here. And when we know about x, x is greater than 8, but less than or equal to 11. And there's our solution. All I did was take these two inequalities right here and stuck them together. You're going to need to know how to do that. I know some of you are probably asking right now, do we have to do that? Yeah, you're going to have to be able to have to do that, okay? All right. Last example. This one's tricky. I want to make sure we went ahead and went over it. Look here closely. Do we have a gap? Very good, Preston. Preston, notice that we have a gap right here on number 9. Because 9 is not colored in, it is not included. So then with that 9 being the only gap, what are we're going to deal with, first of all, we're going to have an or statement, right? What are our inequalities going to be? X is less than 9 because it's going this way, right? And these numbers are less than 9, 8, 7, 6, 5, 4, and all. And then we're going to have x is also going this way, so x is also, or x is also greater than 9. I'm sorry, 12. 9, excuse me. Greater than 9. These numbers right here were just kind of thrown in to trick you. Okay, so don't worry about those numbers. But the circle is on the 9, and you got an arrow going to the right, meaning all the numbers are greater than 9, and you got an arrow going to the left, meaning all the numbers less than 9. And so the reality is your answer, your solution is going to be anything but 9 itself. And that wraps it up. Again, I'm sorry for the longer video tonight, but there's a lot of details and information. Make sure you watch this video. If you need to watch it again, I encourage you to watch the parts that you need again and get ready for class tomorrow. I will see you mañana.